Back in physics, you learned that work was equal to force times distance. Now that's true if you look at the amount of the force. So if F was the magnitude of the force being applied to the object, and D was the number of feet or meters that the object moved, work was equal to force times distance. Now, sometimes the force is not applied in the direction that the motion is actually occurring in. So if the force is actually applied in a direction that makes an angle with the direction of motion, let's call that angle theta, then to find the work, you would have to find the amount of the force that was actually applied in the direction of motion. So we would need to find the vector, the magnitude of the vector for the component of the force that goes in this direction, the direction of motion. Now to do that, we could form a right triangle and use the trig functions. We know that this side's magnitude, we'll call x, can be found by cosine of theta equal to the adjacent side's length over the magnitude of that hypotenuse, the magnitude of the vector. That means then that x is equal to the magnitude of f times cosine of theta, where theta is the angle between the forces vector and the direction of motion. So to find the work then, it's the force times distance when that force is in the direction of motion. So it'll be this quantity, which is the quantity of the force applied in the direction of motion, times the distance that the object travels. Or if d is the direction vector, distance vector, we would say it was the magnitude of f times the magnitude of d times cosine of theta. Well, this application gives us a need to have a new object, something called a new operation called a dot product. Dot product of two vectors, u dot v, is defined to be the magnitude of u times the magnitude of v times cosine of the angle between them. Notice when we did the vector f times the vector d, where f was the forces vector and d was that direction vector, that distance vector, we got the magnitude of f times the magnitude of d times cosine of the angle between them. Now, when you're talking about two vectors, if you put them so that their tails are together, there's always two angles that are between those two vectors. We have an angle here and we have an angle here. One of the two of those will always be less than or equal to pi. So choose the one, when you're refining the angle between the two vectors, choose the one of the two that is between 0 and pi. Now if u or v is the 0 vector, meaning they have no magnitude, then we say that u dot v will be 0. So it's defined, the dot product will be defined to be 0 when we have one of the two vectors, u or v, being the 0 vector. And we'll say that theta is undefined. You can't really find an angle between two vectors if one of them is just a single dot. Now let's look at the definition of the dot product. We have u dot v is the magnitude of u times the magnitude of v times cosine of the angle between the two vectors. Let's say that the angle between the two vectors is 90 degrees. That means we have the two vectors that are orthogonal to each other. Now, orthogonal is just another word that they use to when they're referring to vectors, but it just means that the two line segments would be perpendicular to each other. So if the angle between the two vectors is 90 degrees, we say that the two vectors are orthogonal, and that means that the dot product is going to be the magnitude of u times the magnitude of v times cosine of 90, or pi over 2. But cosine of 90 degrees, or pi over 2, is just 0. So the dot product of two vectors that are orthogonal will always be 0. So when the angle between the two vectors is 90 degrees or pi over 2, the dot product is always 0. Likewise, if the dot product is 0, the two vectors will always be orthogonal to each other. So that's an easy way to tell if two vectors are orthogonal. Check their dot product. If it's 0, the two vectors will be orthogonal. So if and only if u dot v equal to 0. Now parallel vectors, recall parallel vectors means that one of them is just a multiple of the other. They go in the same direction, so you can line them up, move them so that they're placed on top of each other. So two vectors are parallel if one's a multiple of the other. Now if one of them's the negative of the other, then we have them going in opposite directions, but we still say that those two vectors are parallel. So if the two vectors are parallel, in this first case, we have that the angle between them would be 0 degrees. And that would mean then that u dot v would be the magnitude of u times the magnitude of v cosine of 0, but cosine of 0 is just simply the number 1. So that means u dot v will be the magnitude of u times the magnitude of v. Now, if the angle between them is actually 180 or pi, meaning they're in opposite directions, they're still parallel in this case when one's the negative of the other, a negative multiple of the other. But what will happen with the dot product is that u dot v will be the magnitude of u times the magnitude of v cosine of pi, but cosine of pi is -1. So we'll have that u dot v is negative the product of the magnitudes of the two vectors. Now let's look at finding the dot product between two vectors. Recall two vectors are orthogonal if and only if u dot v is equal to 0. The 0 vector will be orthogonal to all vectors because the dot product with the 0 vector will always be 0. And two or non-zero orthogonal vectors will be orthogonal to, perpendicular to each other. Now that's true in 2 or 3 dimensions. Now let's find the dot product of these vectors. I've got u, which is 2i minus 6j, which is in the xy plane. So it's a two-dimensional vector. If we drew it, it would look something like that. And v equal to 12k, the I and j component here would both be 0, 0i plus 0j plus 12k. So if we graphed it, we would be looking at the vector starting at the origin, ending at the point 0, 0, 12. So that vector could be written as a position vector in this way. Now notice that those two vectors, since u is in the xy plane and v is perpendicular to the xy plane, they do form a 90-degree angle. So the angle between the two vectors will be pi over 2, which means then that the dot product will be 0. Or if we want to go through it's the magnitude of u times the magnitude of v, cosine of the angle between them, which we know cosine of pi over 2 is 0. Or we can just use the fact that when the vectors are orthogonal, we know that the dot product is 0. Another example. Let's say that u is the square root of 3, 1. That means if we graph it, this x component will have length the square root of 3, and the y component, this height in the right triangle, will have length 1. The other vector, v, will be 0, 1. Now, if we're trying to find the dot product, u dot v, it's the magnitude of u times the magnitude of v times cosine of the angle between them. So we have two vectors that are both in the xy plane, so they're two-dimensional. We can find the angle between them just using right triangle geometry. So let's look at this angle right here. that will be the angle between the two vectors. Because this length was 1, this height is also 1. And because this length here is the square root of 3, this side up here will also be the square root of 3. So using our trig values, finding this angle, I know that tangent of that angle will be the opposite, which is the square root of 3, over the adjacent side, which is 1. Here's our right triangle. Tangent will have value the square root of 3 when the angle is pi over 3, or 60 degrees. So the angle between them is pi over 3. So now the dot product of u and v, we can find the magnitude of u, which is the square root of the square root of 3 squared plus 1 squared is 2. The magnitude of v will be the square root of 0 squared plus 1 squared, which is 1. So u dot v will be 2 times 1 times cosine of pi over 3. Cosine of pi over 3 is 1/2. So it's 2 times 1 times 1/2, which gives us a value of 1. So the dot product u dot v is equal to 1.